What is up, people? How are you guys doing? Welcome back to today's session. Hoping that all of you guys are doing good and taking good care of yourself. Welcome back. This is going to be the sixth session of work, energy, and power for ICSE 10th. So I hope you guys have been, keeping a track of what all we have done in the past. I hope you guys have watched all the 5 recordings or all the 5 videos before this. Welcome to today's session. My name is Anoop, and without any further delay, guys, let us get started with today's session. So today we will be talking about one of the most interesting concepts that I feel is also one of the most easiest, but also a very interesting concept on its own. That is nothing but the conservation of energy and their conversions. How does it happen? And also we'll try to prove that conservation of energy is actually true for an object. So we'll talk about all of that in today's session. So hope you guys are ready for it, and I hope you guys are once again taking care of yourself. You know what's out there, so please guys take every precaution that is needed to keep yourself safe. But as always guys, we'll be starting off every session with a quote, and you guys know about it already. So the quote for today is this, guys: excellence is not being the best, it is doing your best. It does not matter whether you're the topper of your class or you're are able to answer, you're the best of the best in your school. It does not really matter. All that matters, are you satisfied with what you have done? Do you feel like you've done your very best? That is what gives you more content than being called as one of the best. So seriously guys, I truly believe this, that no matter how good you think that others feel that you are, it's about you feeling that you have given your 100%. That is what gives you that sense of satisfaction and that sense of content. So work towards that rather than like expecting to be the best at anything. Alright guys, so that is all I have to say. With that said guys, let us get started with today's session. So this is going to be the last session of this particular series of work, energy, and power, where we'll be talking about conservation of energy. It's a very simple concept, very tiny teeny concept. Let's try to understand that in as in the most simplest way possible. But yes guys, before that, let's take a look at the homework that I'd given you in the last session, which was basically this question: when an electric bulb glows, dash energy is converted to heat and light energy. And the answer to this question, I'm pretty sure that everyone knows this. It's nothing but electrical energy. Electrical energy gets converted to heat and light energy in an electric bulb. There's no I don't think anyone would have got this wrong. You guys are in 10th grade, do not get this wrong. If you get this wrong, that's all. Anyways guys, with that said guys, let us understand about the principle of conservation of energy. Now, in the most simplest terms, let me define it first. Principle of conservation of energy states that energy can neither be destroyed nor be created. It can only be transferred from one form to another, or it can change from one form to another. This is what conservation of energy is all about. So whatever energy you think that you are, for you to do some activity, you need energy. Where do you get the energy from? From the food. Now, where does the food come from? From the plants. Where do plants get their energy from? From the sunlight. So ultimately, one form of energy is getting converted to the other. It's not that we are producing energy. We know about respiration. You guys know about respiration, how glucose is broken down to produce energy and all of that. You guys know about it. But then, is that where it starts and ends? No. There's a long process beyond that happens, wherein finally it comes out as an energy, in the form of ATP that you can use it. So ultimately what I'm trying to say is this, guys. In simple words, energy can neither be created nor destroyed. It can only be transferred or converted from one form to another. As simple as that. Now, there are a lot of examples around you which actually proves the same. For example, when you get on a roller coaster, you guys know about potential energy. You guys know about kinetic energy. Potential energy is what? The energy possessed by the body by the virtue of its state of position. And kinetic energy is the energy possessed by the body when it's in motion. So when a roller coaster is moving up at the highest point, the kinetic energy over there is 0, but the potential potential energy over there is maximum, right? But as you come down, when it reaches the ground, almost when it reaches the ground, over there, the potential energy becomes 0 and the kinetic energy gets, to be the maximum. So what I'm trying to say is this. You see the big difference? The potential energy is just getting converted to kinetic energy. It's not that energy is just produced all of a sudden. No. It's just that this conversion between potential energy and kinetic energy happening over here. So if you want to find out what is the total mechanical energy of a particular system, you just have to find the sum of the kinetic energy plus the sum of potential energy, basically, or the sum of potential and kinetic energy would give you what is the total potential energy or total mechanical energy. Now, here's the thing, guys. For a system, if you talk about the total mechanical energy, it's going to remain constant. You know why? Because the interchange is happening only between kinetic and potential energy. In an ideal system, that is, all right, where there's no loss in anything, the potential energy is getting directly converted to kinetic energy and kinetic energy is getting converted to potential energy. So for a system, the the total mechanical energy is going to be constant, which means that K plus P, that is nothing but potential energy plus kinetic energy, is going to be constant for a particular medium. No matter which position you take, no matter what point in time you take, it's going to be the same. Now, how do I prove this? That's the biggest question, right? How do I prove that it's constant? Because I can just state whatever I want, but how do I prove this? Don't worry, guys. We're going to verify how kinetic energy and potential energy is going to be constant for a particular medium. Let's take a simple example, all right? Let's take a stone, or let's take a stone or a ball, whatever it is. And let's say the mass of that is m, and I am just dropping it from a certain height, h. I don't know what the height is, but the total height I'll take it as h. All right, very simple. And what I'm going to do is that I'm going to find out what is the potential and kinetic energy at 3 points. One, when it's in the state of rest, when it's at the highest position, then when it's somewhere in the middle, and then when it's just about to hit the ground. I'm going to find out what is the total mechanical energy in both or three of these cases and try to prove that potential energy plus kinetic energy is going to be a constant. Now, here's what I want you guys to understand. When the ball or when that stone is at a certain height h, the potential energy over there is what? mgh. And the kinetic energy over there is 0. Why? Because the velocity is 0, the initial velocity is 0, the ball or that stone is in the state of rest. Let's take it as a stone. The stone is in the state of rest. So u is 0. So what, the formula for kinetic energy is what? Half mv square. So if v is 0, so obviously you get that kinetic energy is also 0. Now, when the ball has reached halfway through, it has reached a certain distance, x. I don't know what that distance is, so I'm just going to take it as x. So that distance that it has covered is x. At this point, when I find the kinetic energy and potential energy, it's going to be a little different. Why? Because the ball has traveled a certain distance. So height from the ground is x, h minus x, which is how you find out the potential energy. But the kinetic energy is a little different, which we'll be discussing as we go ahead. When the ball is just about to hit the ground, the potential energy has become 0 because the height from the ground is 0, h is 0, so the potential energy becomes 0, but kinetic energy over here is going to be maximum. Now, what we're going to do right now is we're going to prove how all of this is related. So, initial velocity of the ball is 0, or the stone is 0. Let's take it as a ball. Yeah, that makes more sense because every time I keep switching between ball and a stone, it can take any object. It does not matter. So yeah, let's take it as a ball. So initial velocity of the ball is 0. So at A, that is at this point when it's above the ground, when it's in the state of rest, u is 0. And the final velocity of the ball is v. The velocity at B, that is, this is A, this is B. Let's take somewhere in the middle as B, and this is C. All right. So at B, let's say that the velocity is v1, and just when it's about to hit the ground, the velocity is v. Simple. All right. Now, what I'm going to do is that I'm going to find out what is the potential energy and kinetic energy at all of these 3 points. All right. So let's start with the first one. When the position is at A, when it's at the maximum height above the ground, the height is h. So with that, the initial velocity is 0. Now, since the velocity is 0, I know that kinetic energy is nothing but half mv square. And I already told you that because v is 0, it will be half m into 0. So 0, that means the kinetic energy is also going to be 0. Simple. So kinetic energy, I'll get it as 0. Potential energy is what? Mass into acceleration to gravity into the height, and height is h. So I'll get it as mgh. So when I add, or when you find out the sum of the total mechanical energy, how do you find out the total mechanical energy? The sum of potential energy plus kinetic energy. Kinetic energy is 0. Potential energy mgh. So what are you going to get? You will get it as mgh. Now remember this, guys. What you got at position O or position A is the total mechanical energy is mgh. Now let's find out what is the kinetic energy and potential energy at position B. Over here, there's a little difference. Why? Because the ball has moved a certain distance x. Now, because it has moved a certain distance x, I have to find out what is the velocity of that ball at that position. So how do I find that out? I'm going to use Newton's, sorry, not Newton's, the third equation of motion, that is v square is equal to u square plus 2as, and try to figure out what is the velocity. Now I'm going to take the velocity as v1 because we've already discussed this, that at position B I'm going to take the velocity as v1. So here also I'm going to do the exact same thing. I'll take it as v1 is equal to u is 0 because the initial velocity, the ball was initially in the state of rest, u is 0, and instead of s I'll take it as x, why x? Because the ball has moved a certain distance x. That is why the ball, I'm checking the the velocity at this position, so it has moved a distance x. So I'm going to, in place of s, I'll put it as x. So what I'm going to get? I'm going to get it as v square is equal to 0 plus 2gx. Now if you simplify it, 0 is removed, so what are you going to get? v1 square is equal to 2gx. Now what I'm going to do, I am going to substitute this value in place of the kinetic equation, or the formula, that is half mv squared. So in place of v1 square, I'll put it as 2gx. So when you substitute that, what are you going to get? You're going to get half m 2gx. Now what will happen? Half gets cancelled. What are you going to get? You're going to be left with what? mgx. As simple as that. So you got the kinetic energy at this position to be mgx. Now I wish I could write it and show it. Unfortunately, I did not have enough space to write it, so that is why I'm showing the step by step, guys. Try to recollect, try to keep up with me. If there's any doubts, let me know in the comment section below. I'll try to keep it try to make it more simpler when we come to the the doubt session. I'll try to make it more simpler for you guys. All right, so anyways guys, so what I'm going to get the kinetic energy of the ball at this position to be mgx. Now I want to find out what is the potential energy. The potential energy is going to be a little different, because why? Potential energy is compared with respect to the ground. I want to find out what is the position of the ball. So with respect to the ground, what is the position of the ball? It is h minus x. Why h minus x? Because the ball has traveled a certain distance x. So what is this distance is what I want to find out. That is h minus x, because the total distance is h and the distance that the ball has traveled is x. So h minus x would give me this distance. Awesome. Now I'm going to put this in the equation. mgh, in place of h, I'll put it as h minus x. Now, I got the kinetic energy to be mgx. I got the potential energy as mgh minus x. Put this, add it up to find out the total mechanical energy. So what will you get? So you'll get it as mgx plus mgh minus x. So I'm just going to multiply mg inside to remove the bracket. So mgx plus mgh minus mgx. So mgx gets cancelled. What are you left with? mgh once again. Now, when the ball was in position A, I found out that the total mechanical energy was mgh. And when the ball is at position B, I'm still getting the exact same answer. So this proves to a certain extent that yes, the total mechanical energy of a system is going to be constant. But we're not done yet. The ball has to reach the ground. We just stuck it in space right now. Let's bring it to the ground. Now when the ball reaches the position C, over here the height from the ground is 0. So directly you can write that the potential energy is 0, because the height is 0, so you can say that the potential energy is 0. Very simple. But to find out the kinetic energy, I have to find out the velocity. I want to find out what is the velocity just before it's the ground. So I'm going to use the third equation of motion once again. V square is equal to u square plus 2as. Now here what I'm going to find out is I'm going to find out what is the value of v square. So how do you do that? In place of s, I'll put as h. Why h? Because it has traveled the complete distance all the way from here to here. It has traveled, so that distance is h. So I'll take it as h. Substitute the value. What are you going to get? You're going to get it as 2gh. V square is equal to 2gh. So in place of v square, half is equal to mv square, I'm going to put it as 2gh. And what are you going to be left with? You're going to get the equation half m 2gh. Now basically remove 2 or 2 gets cancelled, and what do you be left with? mgh. Now, to find out the total mechanical energy, again add up the kinetic energy plus potential energy. Potential energy is 0, kinetic energy is mgh. So again, you're gonna get that the total mechanical energy just before it hits the ground is also mgh. This very clearly, mathematically, indefinitely proves that the total mechanical energy of a system is going to be constant. That is, the sum of kinetic energy and potential energy is constant at any point of time. As simple as that. So from the equation 1, 2, and 3, you can come to the conclusion that the total mechanical energy, that is the sum of kinetic and potential energy, is always going to remain constant at any point of time in motion, and it's equal to the initial position or initial potential energy at that height h, because the initial initial potential energy was mgh, and you found out that at every point it was the same. So basically what is happening, that potential energy is getting converted to kinetic energy. There's nothing else happening. It is just that potential energy is getting converted to kinetic energy, and that's a definite proof that energy can neither be created nor destroyed. It is only getting converted from one form to the other. Now there are a lot of examples of this. So you see this, what's happening is that as the ball is falling down, the potential energy is slowly it is decreasing, and kinetic energy is slowly increasing as it is going to the ground. So you see this, as the height increases, the potential energy increases, kinetic energy becomes 0. But as the ball is coming down, what happens just before it hits the ground, the potential energy becomes 0, or it keeps on decreasing because the height from the ground keeps on decreasing, the kinetic energy keeps on increasing. As simple as that, guys. Now there are a lot of examples. Once again, guys, you can talk about the pendulum. Here in a pendulum, this is the mean position. So in the mean position, the potential energy is 0, but the kinetic energy is not. Kinetic energy is mgh because it's already in motion. But if you talk about the potential, the energy when it's in its extreme position, in one of the extreme positions, you see that in this extreme position, the bob will come to a state of rest. It will stop. Once it reaches the extreme position, it stops. So when it stops, the kinetic energy becomes 0 because the velocity is 0, but potential energy becomes mgh. And when it moves again, when it goes to the next extreme position, again the kinetic energy becomes 0 because the bob would stop, but then the potential energy would be nothing but mgh. Simple as that, guys. I hope you guys understood everything. Now that you've understood all of these, guys, let's solve some questions. But before we get into the questions, I have a very important announcement to make. You guys know the drill, people. I know majority of you guys know about it already, but for all the new guys out there, this one's for you guys. So listen to me very carefully for the next 2 minutes. It's going to help you out really, really well. So listen very, very carefully. So here's the thing, guys. We had given out a simple, a survey. We had asked a survey of what are the problems that you guys are facing on a daily basis on our YouTube channels. And these are the things that you guys came up with, the problems that you guys are facing on a regular basis. The first one, so my doubts are not getting cleared. I have a lot of doubts, and it's not, my doubts are not getting cleared. I have a lot of questions to ask, but then I don't know whom to ask. The second problem that you guys are facing, especially during this pandemic, is that I'm not getting the notes. You guys are studying from a lot of YouTube channels, but then the notes that you get is just not enough. You want more. How do you get that? Thirdly, tests and assignments, because you want to practice, you want to give your best. You can't just go into your final exam and then write the exam. You need to practice. Where do you get these practice questions to make yourselves better? And the fourth is competitive exams, because I'm pretty sure that everyone had the intention of giving your NTSEs and KPY and Olympiads and whatnot. So how do you prepare yourself for that? And then obviously choice of your own schedule, because it's not like whenever you're free, the teacher's free, and you're not free. This is a very big conflict that's been going on for centuries now, and it's still going on. It'll keep on going forever. So how do you solve this problem, right? How do you solve this choice of your own schedule, and also the choice of your own language, because not everyone understands English and not everyone understands Hindi. So how do you solve all of these problems? Here's the thing, guys. At Vedantu, we have solved all of these problems. How do we solve it? It's very simple, guys. In the session, you will not just have one teacher. You will have the master teacher to teach you the concept. Together with the master teacher, you will also have the class teacher to help you clear your doubts. So whatever doubts you have is cleared right there and then inside the class by the class teacher. So you get personalized attention, making sure that all your doubts are cleared right there and then. You get to download all the notes and recordings. So whatever doubts you have, you can go through the recordings, the handwritten notes of each and every session. You can download it, watch the recordings, how many ever number of times that you want, and keep yourself updated about. Even if you miss out a class, you can always watch the the recording as well. You get regular tests and assignments, and that tells you where you're going wrong. And these tests and assignments, in fact, would yield you a personalized report card as well, a performance report card, which gives you an idea of where you're going wrong and what are the things that you can do to improve yourself as well. You'll be trained for your competitive exams, whatever competitive exams you guys are planning to write, you'll be trained for that as well. You can choose your own schedule because yes, the live classes are going on 24/7. Whenever you feel like studying, you can choose your time and study in that particular time. And you can choose your own language. Now, what do I mean by this? Here's the thing, guys. Our classes are not just offered in English, but we also offer classes in Hindi as well. So if you're someone who's comfortable with Hindi, you can always choose that language or medium of communication and get to understand the concept better. It's just that the way that the message is conveyed would be in Hindi. The content, everything remains the same, just that the message would be conveyed in Hindi. That's all, nothing much. So you can choose your own language between English and Hindi, and I'm pretty sure the entire country is divided like that, Hindi and English. So yes, you could choose your own language as well. And apart from these, guys, you have unlimited live classes. You can watch how many ever live classes you want. You have all micro courses and crash courses for free, performance report card like I told you, and you get personalized attention as well. So what are you supposed to do? Click on the link that is given in the description below. Once you click on that link that is given in the description, this is what you're going to get. You're going to choose which grade are you in. You get an option from 1 to 12th grade. Let's say that you're in 10th grade. Once you click on 10th grade, they'll ask you which board do you belong to. Do you belong to CBSE, ICSE or Maharashtra board? Let's say that you, for example, let's just say that you're in CBSE. Once you click on CBSE, this is what you're going to get. What all I've just told you, everything in detail is present here. You can just pause the video and watch it and read it if you want to. Then what you will do is basically click on get subscription. Once you click on get subscription, this is what you're going to get: 1, 3 and 6. Let's say this, guys, let's say that you want to try for the next 30 days and see how it works out. Now for the next 30 days, the base price of that is 4,000 rupees. But don't worry, guys, don't panic. You get a primary discount on that, and especially you'll be paying a price about 2,699 rupees. I know that's a bit too much. On top of that, if you want another discount, use the coupon code AMPRO. If you use the coupon code AMPRO, you get additional 500 rupees discount, and essentially what you'll be paying is 2,159 rupees for the whole month. You can attend n number of live classes, how many ever you want to attend. 24 live classes in a day, go ahead, no one's going to stop you. Alright, let's say that you want to go for the 3-month subscription. For the 3-month subscription, the base price is 10,000 rupees, but don't worry, again, you get a primary discount of 3,000 rupees on that. So essentially what you'll be paying is 6,999 rupees. Bit too much, don't worry, got you covered. You just have to enter the coupon code AMPRO. Once again, guys, click on enter coupon code, enter the coupon code AMPRO, and get additional 1,399 rupees discount. And what you'll be paying is 5,599 rupees for the next 3 months. Let's say you want to go for the 6-month course. For the 6-month course, the base price is 16,000. You get an additional discount, don't worry. 11,499 rupees is what you'll be paying. But on top of that, if you want another 2,000 rupees discount, I'm pretty sure that you guys want it. Enter the coupon code AMPRO, you get additional 2,299 rupees discount, and you get the price to be 9,199 rupees. As simple as that. Alright, guys, so do check it out. What you have to do is click on the link that is given in the description below, and do not forget the coupon code AMPRO to avail the discount, extra discount as well. Try it out. I'm pretty sure that you would love it, and I'm pretty sure that you would see yourself better in the next couple of months. With that said, guys, let's get back to the questions now. Let's solve some questions. Be ready, guys. I want all of you guys to put down the answers in the comment section below. Let me know what is the answer for each and every question. I don't want you guys to wait for me to write the answer. I want you guys to pause the video and do it by yourself. That's how you practice. You don't just sit and expect to be given the answer to your lap. I want you guys to try it out. I want you guys to sweat a little. So here's the question, guys. A spring is kept compressed by a toy cart of mass 150 grams. On releasing the cart, it moves with a speed of 0.2 meter per second. Calculate the potential energy of the spring. Is it 6 into 10 to the power of minus 3 joules? Is it 0.5 into 10 to the power of minus 2 joules? Is it 3 into 10 to the power of minus 3 joules? Or 2.5 into 10 to the power of minus 2 joules? What is the answer for this question? First of all, write down the given data. What and all is given? I know it seems like a bit hard, but then it's actually pretty simple. Alright, mass is given. 150 grams. I'm going to convert this to kg just to keep everything normalized. So it will be 150 into 10 to the power of minus 3 kg, right? Divided by 1000. And the speed, the velocity, I'll take it as velocity, is given as 0.2 meter per second. Alright, now, here's the thing, guys. Imagine a spring. Alright? Imagine a toy car at the end of it. Alright? Now, they've told that the spring is compressed. So basically the spring basically looks like this. It's compressed. The toy car is how I kept it compressed. Now, what happens when you release the toy cart? What would happen? The spring would expand and go back to its original state, because obviously you know about the we've already studied about the potential energy, the elastic potential energy, so it will try to come back to its original state. So this is what the spring is trying to do. So as soon as the cart is released, the spring tries to come back to its original state. So what's happening? The potential energy stored inside the spring is getting converted to kinetic energy. That is what propels the car forward. Yes, the cart moves forward because why? The potential energy, the elastic potential energy stored inside the spring gets converted to kinetic energy. So what's happening? The potential energy is getting converted to kinetic energy. So whatever kind of potential energy that the spring has is getting converted to kinetic energy. Simple. So if I want to find out what is the potential energy of the spring, what should I do? Find the kinetic energy gained by the cart. How would I do that? Kinetic energy is what? Half mv square. What's the mass of the cart? It's 150 into 10 to the power of minus 3. What's the velocity? 0.2 square. Simplify it. So if you simplify it, you'll get a 75, right? 5, 7, 14, yes, 75. So I'm just going to erase this part out. Let me just simplify it. So what are you going to get? You're going to be getting 75 into 10 to the power of minus 3 into 0.2 into 0.2. So what are you going to get? 0.075 into 0.2 into 0.2. If you simplify this, guys, I'm pretty sure if you simplify this, you will get it as 3 into 10 to the power of minus 3 joules. Simple. So what did you do? You found out the kinetic energy. So what I told you, that energy cannot be destroyed, not created. So whatever energy is lost, or whatever energy is does the spring has, is getting converted to kinetic energy. So if I find out the kinetic energy, that essentially should be equal to the potential energy. So if the kinetic energy is 3 into 10 to the power of minus 3 joules, then what will be the potential energy? Exactly the same. That will also be 3 into 10 to the power of minus 3 joules. Simple, people, simple. So you can write that as 3, you can write as 3 microjoules. That is also something that is possible. Instead of writing as 3 into 10 to the power of minus 3, you can write it as 3 microjoules as well. So this is the answer, guys. Option number C would be the right answer. I hope you guys understood this. Let me know in the comment section below if the question was hard or not. But yes, I would like you guys to try it out, guys. Practice a lot of questions, especially in ICSE. There are tons and tons of chapters that you have there. I know that feeling because I've studied in one. I understand it. There are lots and lots of problems out there. I understand, but yes, you have to practice. There's no way around it. There's no shortcut to success. There's no shortcut in gaining marks as well. You have to, mark my words, have to practice. All right, here's the next one, guys. Take a look at this one. Try to solve this one. A bob of a simple pendulum is imparted a velocity of 5 meters per second when it's at its mean position. To what maximum vertical height will it rise on reaching at its extreme position if 60% of its energy is lost to overcome the friction of air? Is it 1 meter, 5 meters, 0.5 meter, or 10 meter? Now this question is a little hutke. So let's say there's a pendulum, guys. All right. So they are telling me that the velocity at this point, at the mean position, is 5 meters per second. What is the maximum height that this pendulum would reach? That's what they're asking me. What is the maximum height that this pendulum would reach if in case 60% of the energy is lost to overcome the friction, the drag or the friction of air? So that is the question. So let me write on the given data first. Velocity is given 5 meters per second. They have given me the energy. Okay, so here's the thing, guys. If 60% of the energy is lost, how much percent of the energy is converted to potential energy? Because at this point, potential energy is 0. But at this point, potential energy is maximum and the kinetic energy is 0. So whatever energy is lost, or whatever is the kinetic energy, that should be the potential energy also. That should be the gain in potential energy as well. So I'm going to find out how much energy is getting converted, how much kinetic energy does the system or does that bob have. If 60% of the energy is lost, 40% is what is left. So how do I what is the kinetic energy? If the kinetic energy is basically 40%, so how do I calculate it? So it'll be half mv square into 40 divided by 100. That will give me what is the kinetic, that is 40% of kinetic energy. What is that? So I do not know what is the mass, so I'll just keep it as m. Velocity is given as 5 square into 4. I mean 0 0 gets cancelled, so I'll get as 0.4. So half into 25 into 0.4 m is what I'm gonna get. Simple. So I'm gonna, okay, so I'm just gonna leave it as it is for now, just to keep it simple. Now I found out what is the 40% of kinetic energy that the bob has is half into, or 0.5 into 25 into 0.4 m. All right, that is the kinetic energy. This should be the gain in the potential energy as well. This should be the potential energy as well. Now, what is the formula for potential energy? mgh. So what is mgh is equal to half into 25 into 0.4 m, because whatever is the energy that is left out, that is what is getting converted to kinetic energy, that is what is getting converted to potential energy. So what will happen? mm gets cancelled. So what are you left with? gh is equal to half into 25 into 0.4. Now let me try to simplify this. So I'll just, okay, so it'll be what, 25 into 4, 5, 4, 20, 4 to 8, 90. So that's 9. So there'll be, let me just erase the first part so that I can make some space for the rest of it. So I'm going to erase this part, guys. I hope you guys have taken a note of it or have at least understood this part. But yes, guys, try to do it by yourself. All right, so I'm going to erase this part. I'm going to write, okay, messed up. All right, yes, guys, so where was I? Yeah, so I found, okay, I got it as GH is equal to half, no, not half. So 5, 4, 20, 0 to 4 to 8, okay, wait, 8, 10, that'll be 10, right? 5, 4, 22, 4 to 8, 10. It'll be, how much? It'll be into 10, so that's 0.5 into 10, that's 5 basically. So GH is equal to 5. Now what is h? I'll take it as 10. So acceleration due to gravity, I'll take it as 10 is equal to 5. H is equal to what? 5 divided by 10. How much is that? It'll be 0.5 meters, I believe, right? So yeah, 0.5. I guess the answer is 0.5, guys. Yes, 0.5 meters would be the answer. That's all. Simple. Little hutke thinking. You have to do a little, little outside the box thinking. But yes, it's actually a very simple question. Once again, guys, I'm going to tell you the steps one by one. First thing what I did was that I found out the kinetic energy. Now, how did I find out the kinetic energy? Because 60% of the energy is lost. Out of 100%, 60% of the energy is lost. So 40% is what is getting converted to potential energy. Because I told you that in a pendulum, when it's in its mean position, the kinetic energy is maximum, potential energy is 0. But when it's in the extreme position, potential energy is maximum, kinetic energy is 0. So whatever is this energy that the probe has, that 40% of energy is what is getting converted to potential energy. So how did I find that out? I used basically half mv square into 40 divided by 100 to get the value of the kinetic energy. Once I found out the kinetic energy, what did I do? I used that, I equated it to the potential energy via a formula, because whatever is that gain in the potential kinetic energy, whatever is the change in the kinetic energy is the gain in the potential energy. So P is equal to K. I equated the equation, mm gets cancelled, so I'll be left with GH is equal to half into 25 into 0.4, and then simplify that equation. You take the value of G to be 10. You can take it as 9.8 if you want to, but then that would make your calculation a little bit more difficult. Try to keep it as simple as possible, because 10 is still correct. So take it as 10, and then you get the answer as 0.5 meters. That's all, people. That's all. With that said, guys, this is going to be your homework for today. Let me know what is the answer in the comment section below. And yes, guys, do not forget to like, share, and subscribe, and click on the bell icon as well, so that you get notified of all the session that comes ahead as well. So homework for today is this, guys. A stone of mass 50 grams is thrown vertically upwards with a velocity of 15 meters per second. Calculate the potential energy at the greatest height. So you're supposed to find out what is the potential energy at its greatest height. If the ball or that stone is thrown up with a velocity of 15 meters per second and the mass of the stone is 50 grams. Let me know what is the answer in the comment section below. I'm not giving you any clue. Let me know what is the answer in the comment section below. I'll catch you guys on the next one, guys. That's it from my side. Thank you for joining. Thank you for being with me. And yes, guys, the link is there in the description below. And do not forget the coupon code AMPRO. See you guys in the next one. Until the next time we meet, this is Anoop signing off for the day. Have a great evening. Do not forget to like, share, and subscribe to the channel. See you guys in the next one. Bye bye, guys. Take care.